So, unfortunately, this is probably going to be a part one. I don't really usually like doing part ones because I don't want it to seem like I'm dragging a project on for too long, but this is one of those instances where that's just probably how it's going to be. This is part one of two. Essentially, what I did was I didn't order throttle bodies until yesterday, and so that would be almost 3 weeks between videos, and I'm trying to keep everybody at least a little bit entertained. So what I'm going to try and do is do this part one basically of the build of the lower intake, and then the second video will be assembling everything and making everything look like it should. So this is probably going to be all the boring nitty gritty of how I actually go through and set up the intake and everything like that. And actually the intake is on the printer, on the 3D printer right now, so I'm waiting on that to get done. And then I'm going to put the throttle bodies on, and that should be the tail end of this week, I'm hoping. So that's the plan of right now. So jumping right to the end, this is the final design for the intake, and I'll break this down piece by piece here in just a minute. Essentially what I did is these stacks are 3D printed, and I'm using a 3D printing material that is very resistant to heat. It's actually the Big Rep High Temp. And I'm interested to see how it does and how these test out. So I flow tested these, and I'll go over that in just a minute, but essentially this is what we're looking at here in this assembly. Obviously these bolt into the factory locations, and the shorter screws just bolt into the 1/4 inch piece that is getting cut out on the plasma. And then I matched the outside diameter of these to the outside diameter of the GSXR throttle bodies, so that'll all bolt up. The other kind of reason why I'm doing this on this motor in this configuration is that the throttle bodies that are on the Porsche cart, I want to go back through them and I want to redesign how they're set up. And I have a few ideas on how I'm going to do that and how I can get rid of some of the major components that went wrong with this set of throttle bodies. So this is kind of a test mule for that at the moment. It'll be interesting to see how it all works. Another thing of note is that this is not really the absolutely correct way to do this, I don't think. I'm sure I'm going to get a lot of comments of, oh, I'm doing this wrong. But this is the way I've always done things. There's a lot of areas I could improve, and I'm still learning new parts of SolidWorks and Fusion 360 every day, but it works for me at this moment in time. I usually design in SolidWorks and then create my cut profile in Fusion 360, although there is sometimes, especially if it's a very surfaced part, I'll build it in Fusion 360. So again, sorry if this is boring for some of you guys, but this is essentially how I go through and how I'm lining up all of these ports and stuff. All the bolt holes were measured, but I just wanted to make sure that my intakes were the general idea, and then especially tracing the outside of how all this was going to go together. Again, this video is definitely more of the design video, how this is all going to go together, and then the next video is going to be actually putting the entire thing together, and not a lot of the build process, but a lot of the actual assembly of the entire thing. Essentially what I did here was I got the basic shape, and then I whittled it down where I thought I could. I'm not too worried anymore about that base plate flexing, mostly because it's going to be bolted individually, and especially with individual throttle bodies, each individual throttle body holds a lot of it on, so it's not that big of a deal to put this entire thing together. Mostly it's just getting it cleaned up, making it look nice, cleaning up some of the curves, getting the thickness set. So of course this is the test piece. I didn't clean it up outside to get anything off that would have hurt the motor or would have fallen in the motor. So let's see how it did. I think I like that. I think we're okay on most of our slots. I'm okay with those. Of course I'll need a little bit of cleanup, and I think it'll get a little bit different, especially with 1/4 inch. So that's why I slotted those. And you see we're at the bottom of our slots, but once we hit up 1/4 inch, that's actually going to be a decent amount. So, but that works out pretty well. Okay, I'm going to get the 3D printed piece printed and then go from there. So this is the end cap design, the two weird end pieces that I couldn't figure out. I had to integrate the hole into the inside of it. I know I'm going to lose a little bit of flow here, and it's going to produce a little bit of dirty air, but I actually flow simulated it, and I'll show you that in a minute. Essentially, it all is the same with a 50mm spacing, but I used the existing model and I just capped over it. So, and here you can see the flow. Well, this is actually a pressure simulation, so where is the high and low pressure on this? And as we compare it to the other, a normal one, one that doesn't have the inlay, I'll show that in just a minute, and you can see that realistically the only part that changes is that little bit of low pressure in where that bolt hole opens up. It actually shows that while it does twist up a bit, it's not. I'm not too worried about any of that. None of that is bad. It's not great. It's not my perfect scenario. If I start to have problems on those cylinders, I will have to either go in and create a cap in there that sits in there that allows it to slide in, but I'm not sure yet. On one of the regular ends, you can see everything works out just fine. You lose a little bit of pressure, but the other part of this is that that's going from a perfectly round hole to an oval shape that's actually a little bit bigger. So, I mean, it's going to cause some problems there no matter what, just in how that's designed. But I'm hoping there's enough air going into this motor that it won't be a problem. And of course, the flow on this is just fine. There's no place where it's catching up or anything like that. So, these are just cutaways, and these are just simple tests on using SolidWorks flow simulation program. So there's no weird tricks or anything here. It's all fairly basic. So we have our two pieces here. The main change, so these are both any one of the four. These are different, and well, actually this one's different, and then this one's different, and of course it's mirrored on the other side. I wanted to take these and install them, or install one on each side. So that'll go on like that, and I don't have this other side cut yet. But essentially this one, they're both supposed to be diving forward and back at the same point, so they'll end up being even, and that way all the throttle bodies are in a very nice pretty line rather than being offset a little bit. So I just wanted to double check that they're in a line, and it looks like they are, so we should be good to go. So at this point, with the the 2 prototypes done. I have a pretty good idea where everything needs to lay. I'm going to get some steel so I can build these. I'm going to build them out of stainless to act as a little bit of a heat buffer. And I needed to add my second points in here. And for these, I'm going to print them. I'm going to order the proper plastic and print them out of the proper plastic, and then get them built up and mounted up. Hopefully the next one will have the individual throttle bodies on, and we'll start in on the Corvette and getting headers built and stuff like that. Thanks for watching.